Hello there, it's Jay here from Jay's Vintage Junk, and today we are back on with the little Portadyne radio. And like I said, unfortunately I had some camera issues with the last recording I was doing this, and I did miss probably about 5-10 minutes worth of the actual video got missed out. So I'm just going to do a quick recap, and then we will get on with today's project, which is basically we're going to see whether we can get this thing to play. We're not going to restore it. We're not going to look at how we're going to power it permanently in the future. All we're going to do is see if we can get this thing to power up and play, and basically assess that it is going to be viable to actually restore into a fully working, functioning radio. So anyway, without further ado, first thing we will do is I will spin it over, and I'll just go through what got missed out from that little bit of a... let's just tip that up a little bit so you can see what I'm pointing at. Let's move this a little bit closer. Can you see that okay? Right, good. Right, basically what we got to on the last video was we removed the old line card dropper, which left us with 3 connections. Basically this connection down there, one up there, and one here. And I got my meter out, got a test meter out, and basically I excuse me, basically what I did is I ascertained that this wire here and that stub there, that is what the asbestos covered resistive line card conductor was connected to. Basically those are your series strung heaters for the valves. That there is our high tension input. Basically that's what we put our AC into the rectifier, and then the rectifier obviously converts it to DC to power the rest of the radio. So we need to put our high tension on there. That is, I believe, what they would have referred to in America as an across the line capacitor. I have given it a quick test just with a meter on resistance reading, and it's not short circuit. For the initial tests, I will leave that in circuit, but that's something to be looked at in the future. So basically that's what we're going to do. We're going to use 2 separate power supplies to run this thing up. What we've got is we have got, I'll spin this around here. This here is my variac. Now what I've done is I've added up all the valves, all the tubes that this thing uses, all the heater filaments, and it comes to 68 volts. Well, I think I said 70 volts yesterday, but it was 68. It's 68 volts, so we can happily round that up to 70 volts. So I've basically got my variac there set to output 70 volts AC, which will energize all the filaments on the radio. But what it won't do is produce any high tension. All we're going to do with that 70 volts is just run the series string heaters in the valves. We're then going to use this contraption here, this slightly Frankenstein-esque looking unit here, which I've owned for many years. I built that when I was still a teenager. What that is a current limiter. It's a current limiting high tension power supply. Basically it produces various voltages from, it does have a heater tap winding, 6.3 volt heater tap winding on it, because I actually originally built it when I was playing with various amplifier designs, making instrument amplifiers some years ago, and that's the reason I actually built this thing. So it produces 6.3 volt AC to run valve heaters. It also produces 250 volts unsmooth DC, and it produces 350 volts smooth DC. And it has the light bulb on top is actually a current limiter. I use this thing for all sorts. It's not just used for running up old radios. I use it for reforming capacitors and, like I said, prototyping valve circuits. It's just basically a very cheap, hacked together current limiting high tension power supply. So that is what we're going to use to provide the high tension to see if this radio is actually going to do anything. and we've got various meters set up so we can basically monitor. We have this, if we look up there, this monitor, this here is going to allow me to monitor the AC voltage on the filaments, and this down here will allow me to see what the output, the current limited output of the high tension supply is. And I will probably also use this little meter here just on the output transformer, so I can just measure what the high HT on the output transformer of the radio is while the radio is up and running. We can just see what them voltages are, make sure nothing's of a silly voltage or not. So yeah, without further ado, let's get this all connected up and let's see where we can get it to run. Now, what I have got to be careful of is that wires obviously come out in a way that I can get to everything, but I don't risk shorting anything out, because we don't want to short anything out at this point. I think I'm going to use these pieces of wood I've got just to lift the front of the radio slightly, just so that I don't trap that wire there. Let's see, can you see what I'm doing here? Right, so basically what I've got is that comes off the heater chain, that one there, and then there's one down on the bottom of this valve holder there, that also comes off the heater chain. That one there is going to be our high tension in, and we can also just ground the other side of that, because chassis is ground on this radio. Right, so without further ado, we've got this unit here. Can you see that there? This is what's called a safe block. That's what's connecting my that is what is connecting my variac there through the safe block to basically to a couple of crocodile clips. And what we're going to do, let's move this back over there so you can see what we're going to do. I've got these crocodile clips, and these are going to provide our low tension to fire the valves up, and that's what we're going to do first. All we're going to do is we're going to connect this up, and obviously I've got to be careful. It is only 70 volts, but you still have to be in mind, you know, there is voltage here. We're going to connect that one to that wire like that. No, we're not. It's not that wire we're going to connect it to. That's the high tension wire. It's that wire in there, which used to have the asbestos dropper, the resistive line card on it. So all we've got now basically is we've got the valve filaments and the dial light bulb there all connected in series. These are all 300 milliamp valves, and I'm presuming that dial light's 300 milliamp as well. So basically it works exactly the same way as a set of the old Christmas tree lights. It doesn't matter whether these are different voltages, providing they're all the same current. They will all add up, like I said, they all add up to 68 volts. So we're putting 70 volts in there. We didn't count for the little dial bulb in that, and we're not sure what voltage that is. So 2 volts for the dial bulb should be absolutely fine just for initial testing. So without further ado, what I'm going to do, I've got the radio switched off, and we will see if we can get it to work on the actual switch there. So I will switch on the variac. I will drop down, so that's the variac on, and we will, if we look up at this meter there, I don't know if you're going to be able to see it, I will shut the safe block, which will then power through to the, there we go. If we look on there, we're showing 70 volts on there. We'll get over to the actual radio itself. We will, in fact, I'll try and shut some of the light off, and we'll see if we can see the valve heater's light. So let's, this is the first switch on one hand, obviously, and making sure I'm not touching anything I shouldn't touch. Let's, well, we switched on, and the first thing that happened was the dial light blew. The dial light bit the dust straight away. So it could be that that was just something that someone has shoved in there and it wasn't the correct dial light for this radio. It could just be that it didn't like being lit after all those years. So what we will do is we will take the dial light out of the equation. We'll just bypass it for now. The extra 2 volts that we're running into it really isn't going to be an issue. But it does look like we do have continuity through the rest of it. So hopefully, I said all the rest of the valve heaters when I do this should actually light up. So what we will do is I do have this switched off, and I do have the safe block disconnected, so I have no power going through this while I actually work on it. So we put this across the dial bulb so we bypass it for now. Okay, so that won't light, that's gone pop. But what we can do is see if the rest of the heater string lights, which it should do. Right now, so that's off. We'll put that down and we'll see. Yeah, we've got our 70 volts now on here, and let's see if we can get the filaments in the valves to actually glow at their correct voltage. We'll switch on, and with no smoke we have, and yes, we have valve filaments lighting. I don't know if everyone can see that on the we can see that on the camera or not actually, but all valves have lit as they should do. None of them have lit unduly brightly or anything, so I think we're quite happy there actually. It was just that bulb, like I said, someone's probably just shoved whatever spare bulb they had in there, or that bulb had really just died from natural causes. It just didn't like the inrush current of being lit again after many years. But yeah, we have, like I said, we have all the filaments lit, and they seem quite happy. They don't seem overly bright or anything. So we'll switch that off and let that die away. And what we will do is we've got the I've actually taken the whole baffle board out of the radio. As you can see, this speaker definitely isn't right for this radio. It would have been a slightly larger speaker, I think, the original, and it wouldn't have used all random nuts and bits and bobs like that to fire it, to fix it in position. I'm not sure about the output transformer. That may have been changed as well. Perhaps there was a fault with the original one. But this does work. I have tested it, and the easiest way to test a speaker and output transformer like this is if you just put a 9-volt battery across the primary there, just touch a 9-volt battery on the primary. If it's the output transformer and the speaker are working, at least to to some extent, you will get some crackles coming out of the speaker. So I've done that, and I've confirmed that the speaker does indeed work, and the output transformer is obviously, well, it doesn't say that there isn't some partial shorts in there, but it is at least working to some extent. So we'll put that behind the radio, and we will get some crocodile clips, and we'll use these to connect. This is where I cut off the speaker wires. We'll replace this with something that looks a little bit more in keeping with a 1940s radio, I think. I don't like seeing that grey flex. It's certainly not really in keeping with the radio. So we'll connect that up, and we'll connect that to one side of the output transformer, and we'll connect this one up like that, and we'll connect that to the other side of the output transformer. We'll make sure that that doesn't short against anything, because that obviously will be at HT potential when we actually fire this thing up. We will get this other little meter I've got here, and we'll use this to monitor the HT that's going into the output transformer. So we can connect that. I think we'll connect it on the transformer. Yes, that way there. So we'll connect that on there like that, and we'll connect the other end of that to a ground point on the chassis. We'll go up there for that. that's a ground point on the chassis there. And the only thing really we need to do now let's plug that, don't need that anymore. Oops. Switch that on and plug in my high tension power supply. Right, there we go. So what we've got the output transformer now connected back up to the radio. We have got the valve filaments are all powered from my variac set at 70 volts. And then all we've got then is we've got the current limited HT output from my HT power supply here. And this is the next thing we're going to connect up to the radio. So what we will do is we will connect this side to the ground point like that, and we'll connect this side, which is the HT, to the rectifier. So we're actually sending rectified DC through the rectifier, so the rectifier really isn't going to be doing anything, but it's just a way of us powering up. I like to call it putting a radio on life support, this, because when you see all the meters and everything connected, it really does look like it is on critical life support. But anyway, what I think we will do now is we'll power up the radio. We'll get the heaters nice and alight, and then we will show it some HT, and we'll see if this radio is actually going to do anything. Right, so without further ado, let's switch on the valves. Let's get the valves nice and warm. Get the valves to light up. And once the valves are lit, we will switch the HT on, and we will see. I'll just show you this because if there's any, basically what happens with this, if there's any dead shorts in the radio, the light bulb there will glow brightly, and we'll know that there is a major issue. That should show us what our high tension voltage should be, and I can adjust that with this control on the front of the power supply. So we've got our all our filaments seem to be lit nicely now. So we'll switch on the HT, and we'll see if this radio is going to give us any life or not, or we're going to get a big bang out of it. So here goes, and power on. Okay. Well, that's dropped right down. We've got about 82 volts HT on this at the moment. We've got about 58 volts on the output transformer, so that's only very, very small. We can possibly increase that with the control. Yeah, there we go. We can take that up using, if you can spot this, there's a little control on the front of the power supply, and that's just connected to a wire wound resistor, and basically allows us to power up the radio. Now, I don't know if you can hear that. That's me just turning the volume control on the radio. So we have got some life up to now. Let's take the HT up a little higher. So we've got what? We've got 100 and let's take it up to 120 volts HT. There we go. We've got about 120 volts on it there. The radio is certainly doing something. If you look down here, we've got I don't know if you can make out on that meter there, but we've got 88 volts on the output transformer so far. If we move over to the radio now, if I adjust the volume control, there is some crackling there. Let's try. There's also some crackling when I adjust the wave change switch. I don't think we'll pick anything up at this exact moment because we've only got very low HT at the moment, and we have no aerial plugged in. That's a very good point actually. These old radios like this, this doesn't have a frame aerial or anything, so we may not get anything without some form of aerial. And what I've got a coil of wire here. It's just the hookup wire that I use for PCBs, and I've just put a radio post on the back of it. and I'm going to string that out across my workshop, and I'll plug this into the back of the radio, and we'll see whether we can get anything with a bit of an aerial on it, see if we can get some reception. But so far we haven't had anything explode, we've not had anything smoke or smoulder. Actually, we are running on a low HT at the moment. We'll creep that up. We'll definitely give a crackle and a pop when I put that into the aerial socket. So let's see. There's something there, if you can hear that. There we go. And shortwave. That's medium wave.
We had to do that because of the fatigue of the players at Bournemouth when they finished the game. There were lots of it.
And if we look,
that's what the first half was.
That's with 124 volts into it. Like I said, we're going through the light bulb as a current limiter. We've got 124 volts going in. We've got 90 volts showing on there on the output transformer. And even at that very, very low voltage. I'm actually quite impressed with this. Let's just get you a bit closer so we can have a look. There we go. It's quite sensitive. It's actually quite a nice sensitive radio.
So we really, you know, turned our.
In fact, the dial's absolutely full of stations, far more than I was expecting. Not very loud, but like I say, we're running on reduced HT. In fact, I'll just put the high tension up a little bit. I'll take it up to 150 volts. There we go, that's on 150 volts HT. That's still well reduced from what it should be.
We get players to stay fit.
As you can see.
We've got to get injured players back in.
And this is with all its original wax leaking capacitors in it. So we have not changed anything. And it's got about 8 foot of wire just slung literally round my workshop. So yeah, mighty impressed with that. I don't think we're going to possibly get anything on shortwave. We'll have a quick go. Certainly there, shortwave. I probably need a much better aerial to get anything on shortwave, to be honest. Something there. Let's give it a little bit more high tension. Let's take it up to 170. It's probably a couple of hundred volts. It's probably what's like 220 volts, 240 volts for its high tension, but we will find out. Like I said, I have no service data for this radio, so I'm just guessing on voltages at the moment. But yeah, it's certainly, even shortwave's got something there. Like I said, I've got an absolutely crap aerial on it at the moment. That will probably improve when I've done replace some capacitors and perhaps done an alignment on it. Alignment might be a little bit tricky because I don't actually know what intermediate frequency it's meant to use. So I could really do with finding out what model of Portadyne this radio is, but I can't find a model number anywhere on it at all. I switch back to medium wave. That way.
Okay, where he goes? Well, he's had a good run, but
yeah, it's definitely quite.
Right. Yeah. In fact,
quite powerful, quite sensitive.
He's going to be the only world champion they have.
Right, well, I'll switch that off now because I think we've run that for long enough. So yeah, that's it. We have now confirmed that the radio is definitely a viable restoration project. So it doesn't look like there's actually really that much wrong with it. We've confirmed that all the valves are at least serviceable. What we will do is probably pull them out and run them through in the valve tester just to see what exactly what condition they're in. I could hear absolutely no hum there really whatsoever. I mean, yeah, we are putting a unsmoothed DC high tension into there, so we will have a look at the capacitors. They may actually be alright. We'll just change the capacitors in it, I think, which will cause an issue to the radio, and then we'll have to look about devising a power supply for it to allow us to use it safely on UK mains. Now, a chap did mention after my previous video about different power supplies to power this thing with, and he pointed out something which I'd already, to be honest, I'd actually done the calcs myself. I can't use just a dropper resistor with this thing because it would need to be about 50 watts, which is quite frankly a bit ridiculous for a dropper resistor to produce far too much heat. And what he mentions, it's something I have used a long time in the past. I haven't gone back to it for a while, but I think I probably will do for this radio. It's something called a capacitive dropper, which basically uses a capacitor in series with the mains, and it produces a phase shift in the mains, and basically that's the way that it drops the voltage. And I think he come up with a value of 4.1 UF, which I think I can probably muster up with the capacitors that I've got. I think I might have some old motor run capacitors that are just like 4 UF, and I'm sure I've got some main suppression capacitors of 0.1 UF, so I could probably get there, and I will run my heater chain like that, and then it's just a case of deciding what I want my mains voltage into the rectifier to be to provide whatever HT supply I want. I can either connect that directly in as it was before, or I can run it perhaps through a resistor and drop it down. We're going to have to play with that, and we can play with that better once we've got the valves running from their capacitive dropper, because we can then use the power supply and the variac to decide what we want our HT voltage to be. Anyway, I'm going to leave it there for now. Like I said, in the next video I think we'll be doing some capacitor replacement on this, and we'll be looking at devising a more... Yep, my camera did it again. Anyway, I actually spotted it do it that time, so as I was saying, what we will do in the next video, like I say, is probably recap the radio, and we will come up with a better, more permanent power supply solution than using that monstrosity there and my variac over there, which is what we've used today to actually prove that this radio is a viable repair. So I'm going to leave it there for now. I hope you enjoyed that installment in this restoration. So thanks for watching, and goodbye.